And we are recording now. Sam?
Yo, what up?
Bam.
We're recording the lesson.
We're recording the lesson. Yeah. Yeah, you're famous now. Everyone on the internet has heard your voice now.
Oh, no.
So we're on lesson 4. Let's go ahead and fill in the formula that we just worked out. A is ABCD. And the inverse matrix of A is given by, hey, see if you can write it down without looking at your notes. So first things first, I want you to write that anytime you're talking about inverse, A negative 1 is equal to fraction 1 over determinant of A down diagonal, switch. The D goes where the A was, the A goes where the D was. Up diagonal, negate. The C becomes negative. The B becomes negative. No switching happens there. Okay. So let's actually use this to determine the inverse of a matrix. Here's our matrix. Negative 1, 2, negative 3, 4. Step 1 is compute the determinant. Okay, recall that our determinant is product of down minus product of up. Okay, let's see, what does that give us? Negative 4 plus 6 is 2. So that's step 1. Everybody good with that? All right, step 2. Write your inverse matrix like this. Fraction is 1 over, pick up that determinant value right there, bring it down here, plug it in to the denominator, multiplied by and now we switch. So this was negative 1, 4. Let's make that 4 and negative 1. Up diagonal was negative 3 and 2. So the 3 goes positive. You change the sign. The 2 goes negative. There's your inverse matrix. I do want you to clean it up by getting rid of the fraction. And anytime you're doing scalars, that just means you multiply it through. So our matrix would end up being half of 4 is 2, half of negative 2 is negative 1, half of 3 is 3 halves, and half of negative 1 is negative 1 half. Okay. If you have a functioning inverse, 2 things should be true. The first is this. If you take A and you multiply it by its inverse, you should get a particular matrix. What is that matrix that you should end up with, folks? Very nice.
Ooh, that's cool.
Okay. It also has to work in the other direction. So if you take you know how we talked about last class, how when you switch the 2 matrices, you don't always get the same answer? Okay, it means they're not commutative. These have to commute. So when you switch the A inverse and the A, you still better get the identity. So let's just check that quickly for our 2 matrices. Our first one was negative 1, 2, negative 3, and 4. And our inverse is 2, negative 1, 3 halves, and negative 1 half. Okay, let's find entry 1, 1 right here. Brendan, could you help me out with that?
It's negative 1 times 2,
Mm-hmm.
and then 2 times 3/2.
So that would be -2 and 3 is going to give us 1. Is that what we want? Okay. Okay. Sam, get the next one. What's going to go in entry 1, 2?
0,
Are you sure?
sure,
Let's check. -1 times -1 is?
1,
Okay. 2 times -1/2 is? 1 plus -1 is?
0.
Okay, feeling good about that one. Let's go to right here. Anthony, help me out with what's going to go in 2, comma 1. How do we do that calculation?
It's going to be 0, it's going to be -3 times -2 plus 4 times.
Hang on, I think you got it turned around. You want to take this and multiply it by that.
Oh, yeah,
So you're going to get -3 times 2,
plus the 4 times.
and that's going to give us the 0. Okay? So we got that. Griffin, get the last one. What's going to go in this position right here?
1, 33, and then -2.
Which is going to give us 1. Okay. I'm going to be quiet for a second. I want you to check the other one. I want you to check that 2, -1, 3/2, -1/2 times -1, 2, -3, 4 works.